Okay, we're going to learn how to factor higher degree polynomials using previously learned methods and using grouping, which you haven't done before. Then we're going to use the factored form of a polynomial to get the x-intercepts and their different types. Types, what are they talking about? All right, remember, we're about halfway through a unit. And right now you're supposed to be able to say things like, oh, I know that one is a bounce, and that's one type of a root. And this one over here just passed through at, let's say, 5. So this equation would look like this. It's got factors, x plus 3, and it's a bounce, so that's squared. This one's passing through at 5, so it looks like that. This one was a bounce, this one was not a bounce. Are you with me so far? Was there any other kind besides a bounce and a pass through? Yes. This kind. And that one is, this is just a pass through, but that one is special. It's a degree what? Degree 3. Because look at just this part of the graph. That's y equals x to the third. That's a third degree. So this was, the equation for this one would have been y equals x to the third, because it was at 0 where it went through and it had this curvy shape. Sometimes I call it a snake, but you could just say it passes through. And then it also went through here, and let's say that's at like 9. Then this would be x minus 9, and it just passed through, so it's a power of 1. All right, so when they talk about the different types of roots, this was a triple root. This was just a single root or a normal pass-through. Okay, so we're going to be factoring things that have x to the third in them, for example. So without further ado, I'd like to give you one. X to the third plus 3x squared minus, let me think, 9x minus 27. Now, what's different about this than you've ever done before? It's got 4 terms in it. You've never done that before. Okay, so you're stepping up a notch. Another thing I like about this class is, even though most of you guys are freshmen or sophomores, you could hit an average person out on the street with this, and they had to like figure out, we'd just tell them to solve it, or tell them to factor it, even give them that hint, you got to factor it. Almost nobody can do this. But you will be able to. It's really not that hard. Okay. I'd like you to, just for a second, you know you can undo, right? Just for a second, scribble that out. Act like that's not even there. If that wasn't there, could you factor the first part? Yeah. Well, undo that scribble because we need the rest of the problem, but act like the end of the problem isn't there. And just factor this part. Do you get there's an x squared in both parts? Then, look at just this red part here. Now you may recall, or maybe you don't, that I said if you ever have a negative in the front, you need to get that out of there. You need to factor that negative out. But there's more than just a negative. What else factors out of that? Yes. Negative 9 factors out of it, and you get what left when you factor out a negative 9. Don't say it. Don't say it. Just do it. When I factored the blue part, and I took the x squared out, really what's happening is I'm dividing both parts by x squared. I really want to be known as the person who explains why this answer is what it is. And it's because when you divide by x squared on both of these, you'd have x plus 3. And then here, we divide this by negative 9, divide this by negative 9, and you get x plus 3. do you think it's a coincidence that we got x plus 3 in both parts? No, it was set up that way on purpose. Because now you should look at this as a big complicated term and this as a different big complicated term and say, what do they have in common as a common factor? What do they both have? X plus 3. That's what they both have. They both have a times x plus 3 in them. That means it's a factor. So what do you do again? You divide by that x plus 3. That's what you do when you factor something out, is you divide by that thing. And what you're left with is what's left and goes in here. I factored out the x plus 3, and I got x squared minus 9. Does anybody have any questions or thoughts? Or all right. Well, yes?
Couldn't you factor out the x squared minus 9?
Yes, I was hoping somebody was going to say that. That's why I said, do you have any thoughts? Instead of like, do you have any questions? Yes, you can factor it again, and that's going to be the most important thing on your next test. There's going to be tons of factoring on this next test. Probably 4, at least maybe 4, maybe 5 questions where you got to factor. And people will factor. This is factored. It's just not factored all the way, because this can be factored again. And I have x plus 3. And then this one factors into x plus 3 and x minus 3. And then you got to notice that those two are the same. So there's a bounce at one of my roots. Look at that. Now that is some hardcore factoring. That's called factor by grouping. And then at the end, it was just plain factoring. Do you think that's the hardest thing you've ever factored? Probably is. Do you think that's the hardest thing you will ever factor? Nope. Because it's the first day of adding on really hard factoring problems. So we got even harder stuff than this. But we should practice this factor by grouping for a while till I know that you all got it. All right. So let's go into the regular slides here and look at the first one. This is just kind of normal factoring. You know how I can tell? It's got 3 terms. So you can just make yourself 2 sets of parentheses. Oh, but wait. Is there a 3 in everything? Then don't make 2 parentheses. 2 sets of parentheses. Just factor out the 3 first. Because if you can factor out a GCF, you should. All right. So everybody factor out that 3. And then factor it again. You have to be a algebra ninja to be able to do this kind of factoring. Okay, did you get x squared minus 2x minus 8? Good, then did you factor it again? Madison, what'd you get? Okay. Would you agree it's x and x?
Yeah.
Would you agree it has to be a plus and a minus? Think it through, and maybe I'm messing with you. Do you agree it has to be a plus and a minus to make this a negative 8?
Yeah.
Yep, it's true. Fiona. Know how to do it? These 2 numbers here and here have to multiply to 8. Now, I can't expect you to guess right the first time, but at least tell me something I could try. 4 and 2. So I just slap them in here, and I see if that was the lucky draw. And I go like this, and I get 4x, and I go like this, and I get negative 2x. So, Fiona, did that work? Did I get exactly what I wanted? No, because I wanted negative 2x. So what should I do?
It's like plus 2 and -4.
Yes, so switch the signs. This is plus and this is minus. And now this will be negative 4x and this will be positive 2x. And it gives me what I needed. There it is. That's factored. But no special prizes for getting that one right, because that's the kind of factoring we've done before. I'll go to this one. There's something weird about this factoring. It's still got 3 terms. There isn't any GCF because there's no like X in everything and there's no 2 in everything. So there's nothing I can get factored out first. So then I just go to 2 parentheses. See if you can figure it out. Sina, give it a shot.
I had like x squared plus 2.
X squared and x squared. I always start with these. Would you agree so far? Did you say plus?
Yeah, plus 2.
And can it be a plus and a plus? Like I always do my signs next. So I'm trying to stay consistent with the way I always do it. Can it be a plus and a plus, or can it not be that?
No, it can't.
Can't be that. It has to be a plus and a minus. How do you know that?
Because there's negative.
Because this is a negative 8, and there has to be a plus and a minus to make that. See how this, so far I can just use logic? It has to be these. So, Ethan, give me some options. What could I put here and here?
4 and 2.
All right. And I'm not sure if it's going to work, so I try it, and I stick in a 4 and a 2, and then you check it. You go outside, inside. 4x squared, negative 2x squared, and Ethan, is that giving me exactly what I wanted?
Yes.
Yes, because it's positive 2x squared. That's what I got. Cool. Now the only question is if you could factor it further. Did you even look? Because if you looked, you win. That doesn't factor further, and that doesn't factor further, unless you want to go into the I thing I taught you. Just a callback to the past. I would not have said, oh, you need to know this, but it would have worked. Oh, wait, I'm wrong. 2 and 2. Sorry. Not square roots of 2. It's not that complicated. But it'd be 2i and 2i. Now, again, that's kind of extra, but I did show you that once. Yes?
Why would it be 2i?
Because if I use just a normal minus and a plus, that won't work because I'd get a negative answer. If I use a plus and a plus, I would end up with a 4x term in the middle of the thing. So I need to have a plus and a minus so my outside and my inside terms cancel, and then the I times I makes I squared. But again, I'm making this just a little too extra. This is hard enough, class. I'm just throwing it in there for the extra bright kids who are in here going, I get A's on everything. Okay. All right, so that's it. It's factored all the way. Because you can't, unless you use imaginary numbers, you can't factor these further. Okay. And this one you could actually technically factor it to that, but I would not make you do that. Why? Because you're not supposed to use weird numbers here and here. You're supposed to use just whole numbers. You're not supposed to use decimals, or especially square roots, which go on forever and never repeat. So this would be factored all the way. All right, on to this one. It's like the other one, but you got to do something first. pause for a second. Let me give that a try. Okay, so we factored the 2 out. Then just take it one step at a time. Do you get it has to be x squared and x squared? Well, that's not that hard. Do you get it has to be a plus and a minus? Because that's negative. You have to use one positive and one negative. And then it probably has to be a 9 and a 2. But I just guessed wrong. You know how I know? Because I did this in my head real quick and I got positive 7x. That's the opposite of what I wanted. Then don't change the numbers, change the signs. And if you got that far, good for you, but you're still wrong. Unless, what? Unless you noticed that it factored one more time. X plus 3, x minus 3, and x squared plus 2. Okay, now the questions that we give you will ask both to factor it, like we just did, and then tell what the roots are. They're also the x-intercepts, they're also the zeros. Do you know the answer?
Oh no, I have
You have a question? Go ahead, what's your question?
Okay, so if you put x plus 3 and x minus 3 into negative 9, why wouldn't you do x plus 2 and x plus 1 as well?
Okay, so let's just, his theory is that we should be able to do x plus 2 and x plus 1 to factor this. So the way I just...
They might actually, they don't say so.
Yeah, you just have to check this and you go, wait a minute, that's not working. So always go back and multiply them out and see if that works. Okay, good question. I really appreciate that you asked it. All right, so now I've got this and I would have 2 blanks on the test. One is for the factored form. Done. The other is for what are the real and imaginary... No. Yeah, actually there will be. There'll be 2 blanks. Real roots. Imaginary roots. Okay, well the real ones are pretty easy. X equals 3. Remember, roots are the same as zeros, which are the same as x-intercepts. So it's 3 for that one, and x equals negative 3 for that one. Does that make sense to you? These other ones are imaginary. You know how I know? Because if I make this equal 0, that's the point. That's what these do. 3 makes this one equal 0. Negative 3 makes this one equal 0. What makes this equal 0? Nothing. There's nothing you could put into x that would make this whole thing equal 0. Because whatever you put in there is going to get squared. So you can't get something to make it equal 0. So it's giving you imaginary roots. So what's the secret? You do this. X squared plus 2 equals 0, and you solve it. This goes back to a previous test, which was on complex numbers. You're going to have I in your answer. Warned you. Heavy duty stuff. So at the end of this test, we're going to have square roots and negatives involved too. That's like one of our previous chapters called complex numbers. X squared equals negative 2. Okay, question or comment?
Square root of 2.
Well, we're getting there. Okay, just let me do one step at a time. I subtracted 2 from both sides. I'm going to square root, and then, oh, so many people on the test screwed this up, but a fair number of you remembered. What happens exactly next? Yes, absolute value of x. Because if you just say square root of negative 2, you missed it. Because there's 2 answers. This could be square root of negative 2, or it could be the negative of the square root of 2. So I got to get 2 answers now. And I should get that negative out of there. Do you remember this deal that this is really the square root of 2 times the square root of negative 1, and that's really I? So and there's more than one answer. There's 2 answers. All right, welcome to your hardest test. Not of the year, but definitely of the semester. This isn't impossible, but look at all the little steps. now I gotta split this up into two parts. X equals I root 2 and x equals negative I root 2. And yes, at this moment, I would have allowed you to simplify that and just say x equals plus and minus I root 2. But tons of you on your last test on complex numbers forgot the plus and minus. Tons of you on the cumulative still forgot the plus and minus. And it's going to happen again on this next test. Okay, so when you're square rooting the variable, that's the moment. Because if you put absolute value bars here, you win. Because then you'll remember, oh yeah, to get it out of the absolute value, one can be positive, one can be negative. All right, so those guys are your imaginary roots I asked for. Plus and minus I root 2. Whew. So not only hardcore factoring, but understanding complex numbers. I'm serious. Hardest test that you've had. Okay. All right. So let's do another one. First, always look, is there anything in everything? Is there any common factor? Yes, there is. What's in everything? X. So factor it out. If you find yourself doing, and you're like, I can't factor this thing, it's usually because you forgot that there was a GCF. Carter, Mueller, what do you get after you factor out the x?
You get, would the x cubed turn into x squared?
Yes, it would.
So you get x squared plus 6x plus 9.
Perfect. And then you always should ask yourself at the end of these questions, can I factor it again? Yes, you can. And sometimes we have it so you can factor it a third time. There we go. Not required, but encouraged. There's two things like that. Not required that you put them together like I did, but it's encouraged because then you'll go, oh yeah, it's a bounce there, which helps on the graphing parts of the test. Okay. D. But try that one without my help. You got this. We're almost done. See if you can focus for another 5 minutes. If so, we'll have a little change of pace. We'll get you into your homework.
Can I fill my water?
Do this problem first. Macy, what did you notice was in everything? Correct. 4x comes out. Macy, what'd you have left? That it? Plus 1. Because really what's happening is you're dividing by 4x, you're dividing by 4x, you're dividing by 4x, and what's 4x divided by 4x? 1. Okay. Can I stop? Nope. Got to keep factoring. Madison, what'd you get?
X minus 1 and x minus 1.
You are correct. And then encouraged but not required. Because then you'll go, oh, it's bouncing there, and there's also a root at 0. And if I asked you for that follow-up question, like, what are the real roots? This would be an easy one. X equals 1, x equals 0. Those are called the roots, the zeros. They're also the x-intercepts. They're also called the solutions to the equation. All right. Now, from here, it just gets to be more complicated ones of the same things that I've been showing you all hours. So I want to go to a good one that has factor by grouping. Go to this blue one. We practice factor by grouping, but not since the beginning of the hour. So this is the last really important kind. Can you factor by grouping yet? Can you see something in the first two parts? Then, separately, can you see something in the last two parts. So factor out the first part, factor out the last part, and put it all together. X squared comes out of the first part, and I get x plus 3. 2 comes out of the second part, and I get x plus 3. Whenever these are the same, then that's the common factor. I'm putting a plus right here, and that's kind of an important one. So you can see there's two separate terms. There's this term and there's this term. And what's in common? X plus 3 is. If I divide this by x plus 3, and I divide this by x plus 3, you'll see what's left and what goes in here. Cancels, cancels. X squared plus 2. Raise your hand if you had that one right. That's called factoring by grouping. All right, do you have to be an awesome at this right this second? No. This is the first time you ever learned it. But by the test, which is coming near the end of next week, you got to be awesome at this. Yes?
Are you not supposed to factor the x squared down anymore?
Good question. If this was a minus, that's your clue that they'll factor easily. If you want to be a extra smarty pants, extra guy, you could go like this. X plus square root of 2i and x minus the square root of 2i, but I would not make you do that. That's the only way you could factor it otherwise. Okay. This is the part where we need to get into the homework. Everybody find the homework. Open it up. I will cut it down to a reasonable size because I'm a reasonable person. I think it happened first when I had kids. And I started seeing my kids get their homework. And I was like, holy crap, if every teacher gives you a half hour of homework, you have 3.5 hours of homework. Like, and then if you have sports too, and you have to eat in the evening, you'll have no life. You have nothing else you can do besides homework and your sport, and that's it. You can't even have an hour to watch Netflix or something, or talk to your mom or anything. So, bottom line, I'm trying hard to make your assignments reasonably sized. So please find your assignment with me, and I'll tell you which ones to skip. Okay. Number 1's good and important. So is number 2. Number 3 could be, could go away and it wouldn't hurt anybody. So everybody cross off number 3 and the follow-up questions to number 3. Let's go skip number 3. And skip number 6. Now, of course, you can do them, but skip 3 and 6. That'll keep your assignment reasonable. Now, let's do number 1 together. Keenan, can you tell me how to start the factoring when it has an x to the 4th in it? Well, let's have 2 sets of parentheses.
X squared and x squared?
Yes, x squared and x squared. Next, you always look at the signs. I have a negative in my problem. There must be one negative, automatic. Then you look here, and you see, wait a minute, if I had a positive and a negative, then this wouldn't come out negative. So by logic, it has to be a negative and a negative. You can know that. It's positive. It's got to be minus and minus. It's the only way it would work. And then last, you got to get a 36. My gut says it's not 6 and 6 because then, think about it. These would cancel each other out. No, they would actually make 12, and I need 13. So it can't be 6 and 6. So what's the other choice? What makes a 36? Am I the only one that knows it's 9 and 4? Now, why, pray tell, do you think they picked 9 and 4? It's right. This is it. That was the answer. It's not that. It's something that we're going to do. Yes? Because then you can factor both of them again. You get what I mean? Like if they would have just ended with x squared minus 7, you wouldn't be able to factor it. Or x squared minus 2, you wouldn't be able to factor it. Think like a teacher. We want to get you to notice, even on the first problem, that look at these things. They factor out so far. Now, nothing in their factors again, does it? No, there's not even anything squared. So, now I did say that if you could put things together like x plus 3 squared, but there's nothing that's actually exactly the same. There's no like x plus 3 with another x plus 3 that we could put together. So, finally, I'm done. Now, I got to go to the zeros. These are all real answers, just as easy as they can be. Negative 3 makes this part 0, 3 makes this part 0, 2 makes this part 0, and negative 2 makes that part 0. Now, there wasn't anything imaginary in there. Carter.
Couldn't you just factor out the x's in each one?
Factor out the x's. What do you mean by that?
Like all of them are x's and we can just move them?
Nope. That would not work. Thank you for asking. I get what you're thinking. You're thinking there's an x in everything. But those x's are part of adds and subtract problems. So that means you can't factor those out. All right, so there's my 4 roots. They're also the x-intercepts. They're also the zeros. Cool. Got the first one done. Number 2, it's a little weird, but still factor by grouping. I'm going to make one part black, I'm going to make one part red. The black part, something factors out. The red part, something factors out. All right, that's all I have for you for today.